Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good morning to my beloved lecturer and friends. First of all, I would like to thank our beloved lecturer Puan Normaizan binti Abu Bakar for giving us guide to complete the assessment. So before we start, I would like to introduce myself and my team members. So starting from me, my name is Alif Amiri Adli bin Hisham. My metric number is 01DKA21F1094, and we have Nur Sarah Liana binti Nur Azizi. Her metric number is 01DKA21F1084. And for the second member, we have Nur Syafiqah Zahira binti Muhammad Nasir. Her metric number is 01DKA21F1106. And for the last one, we have the one and only Muhammad Nasrul bin Muhammad Khairi. His metric number is 01DKA21F1073. Okay, so this is our table of contents that we will present to all of you in the next slide. So let's get started. So I'm here to tell you about the introduction. Let's go. As you can see, leveling is a branch of surveying object which is to establish or verify or measure the height of specific point relative to the datum. It is widely used in geodesy and cartography to measure geodetic height, and in construction to measure height differences. So it was divided into two major categories, which is plane surveying and geodetic surveying. For plane surveying, it's referred to the survey of small extent where it's assumed that the mean surface of the earth is a horizontal plane for the area concerns. For geodetic surveying, it's referred to survey of the largest area where the above assumption of the earth as horizontal planes is invalid and allowances must be made for the curvature of the earth. Next, I will show you some of the terms that I use in leveling. So the first term in leveling is benchmark temporary. It is fixed point but are less permanent in nature and are formed close to the survey site to save reference, work to stepping stones that may be too far away. Next is a benchmark. A benchmark is a fixed reference point located on the surface of the earth where the level has been known to measure its height by reference to a specific datum. The reference date is usually the mean sea level, or known as MSL. The next term is datum. Datum is a set of reference points on the earth's surface against which position measurement are made which something can be measured. The next term is reduced level. Reduced level is a vertical distance between survey point and adopted datum plane. Thus, it is considered as the base elevation which is used as reference to reckon height or depth of other important place. So after that is a change point. Change point is the start position point at which two readings are made. The next term is a backside. It is the first observation is taken after the level is set up at one's position or the first reading is taken above a point of known height. So next is intermediate side. It is a observation taken between the rear view and the front view. So for the final term in leveling is foresight. It is the last observation before the level is moved to another point, position, or a staff reading taken above a point where the height measurement is to be determined. So I also will tell you guys about the objective for our assessment. So let's see in the next page. So here we go. Our first objective is calculate the height difference between two locations. Number 2 is establish standards and standard benchmark. Number 3 is obtain the soil profile, cross section and length. Number 4 is topographic mappings. We make a contour maps. Number 5 is concentrate on peak control measurement. Number 6 is land slopes are assigned for certain users. Number 7 is to determine the land boundaries. And the last one we got to show the relative position of the object on the surface of the earth. That's all from me. I will pass to Nur Syafiqah Zahira.
Thank you to Amiril. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafiqah Zahira binti Manasir and our metric is 01DKA21F1106. Next, I would like to continue this presentation by presenting about the equipment available in the survey. Among the first equipment is the dumpy level. It consists of a bubble commissioned on a telescope, which which is supported by a top plate. This level telescope can only rotate in the horizontal plane. Dumpy levels are optical measuring devices that are used for accurate measurement in the same horizontal plane, where a precast telescope and bubble level. They can be either manual or automatic in their setup, although both require careful adjustment on the tripod to ensure the instrument is level before use. Secondly is tripod. A tripod is used to support the leveling equipment. Tripods provide a stable base for all types of surveying instrument and setting equipment. Instrument produce standardized surveying tripods. A surveying tripod is a device used to support any one of a number of surveying instruments, such as theodolites, total station, levers, or transits. Next is staff bubble. Air bubbles are used to keep the setup upright, usually mounted on the side of the staff. For a measuring tape, the distance from the level to the staff is measured with a measuring tape. To avoid two collimation variation, the distance between the back side and the fore side should be nearly the same. There are 4 types available in surveying for liner measurement, which is first liner tape, woven material tape, steel tape, synthetic tape, and lastly inward tape. 5 is surveying booking form. An external spreadsheet is utilized to record readings and calculate customizable levels. The rise and fall or head of collimation method can be used for bookkeeping and counting. 6 is level staff, used to calculate the head difference between 2 points or the head of 2 points above a vertical datum. And lastly is change plate. It is a small flat metal plate with a rest point in the center that is used to support and stabilize the staff on the ground. The plate is firmly embedded into the ground to stop the staff from subsiding. Next, I would like to present about fieldwork procedure. As you can see, this is the leveling field procedure that should be followed shown in figure 1 below. First, to start the fieldwork, you must set up the leveling instrument at level position 1. Next, for the staff on the datum, which is RF plus 50 meter, and take a reading. This will be a backside and the position taken is 2.554 meter. This because it is the first reading after the leveling instrument has been set up. After that, the staff is moved to point A with the reading taken being 1.786 meter. This will be an intermediate side. Also, move the staff to point B and C and read the value at both position taken is 0.927 meter and 1.983 meter. This also will be an intermediate side. 5. Move the staff to point D and take a reading of 3.589 meter. This will be a fourth side because after this reading the level will be moved. After that, set up the level at level position 2 and leave the staff at point D on the safer point. After that, turn the staff and take a reading of 1.305 meter. This will be a backside. Then, move the staff to point E and take a reading of 1.422 meter. This will be an intermediate side. Also, move the staff to point F and take a reading of 0.501 meter. This will be a fourth side because this point is the safer point. And after that, the level will be moved. Now, move the level to leveling position 3 and leave the staff at point F on the transfer point. The reading will be 3.250 meter. Lastly, repeat the step, describe 7 to 9 until you finish at point J. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasrul bin Muhammad Khairi. My metric number is 01DKA21F1073. Okay, next I will explain about analysis and data calculation based on rise and fall method and height of Kalimantan method. Okay, first I will explain about rise and fall method. Okay, and here we got backside column, intermediate side column, rise column, fall column, reduce level column, and remark column. Okay, first at the backside column we has 2.544, and then intermediate side column we got 1.786, and then 0.927 and 1.983. Okay, next we go to fourth side column. We got 3.589,
and at here we need to change point into the 1.305, and then back to the intermediate side 1.422, and then for side 0.571, and then change point again to the 3.250, and then intermediate side 1.925, and then for side again 0.462, and change point again into the 3.015. Okay, next I will explain about how to calculate rise and fall method. Okay, at first we got at the back side we got 2.544, and then we minus intermediate side, which is 1.786, and then we got 0.768, and then we minus at all, and if we got negative value, we take it to the 4 column. Okay, and then and for reduced level calculation, which is first we take it from the datum from the diagram, which is 50, and then you add or minus based on the rise and fall column, and at the last reduced level final, which is we get 554.722. Okay, next I will explain about how to calculate arithmetic check. Okay, the formula we got back side minus foreside equal to rise minus fall equal to reduced level final minus reduced level start. For example, 10.124 minus 5.402 equal to 4.722, and then 7.501 minus 2.779 equal to 4.722, and last one 54.722 minus 50 equal to 4.722. The last answer for all this calculation will be same. And then the lastly check mesh closure, which is equal to 5 square 4 equal to 10. Okay, next we go to height of Kolimatan method. Okay, based on the table, we can see the the column is like rise and fall method, but there is no rise and fall column, but it has height of Kolimatan column. Okay, how to calculation is first we need the height of Kolimatan, which is 50, and then we plus with backside, which is 2.544, and we will get 52.554, and then we calculate until the change point, which is we get 48.965 plus 1.305, and we will get 50.27, and then next change point is 49.699, we plus 3.250, and we will get 52.949, and then next change point 52.487 plus 3.015, and we will get 52.487. Okay, and lastly I will explain about how to calculate arithmetic check based on height of Kolimatan method. Okay, the formula equal to backside minus foreside equal to reduced level final minus reduced level start. For example, 10.124 minus 5.402 equal to 4.722, And then 54.722 minus 50 equal to 4.722. And lastly, check disclosure equal to 5 square 4 equal to 10. Okay, that's all from me.
In conclusion, the leveling has importance in the field work, including it helps surveyor or cartographer to take contour maps of the land surface. It also helps in construction of roads of transport like roads and railways. Moreover, leveling also helps contractors to lay a level ground on which they can elect a level building and pipes transport to ensure appropriate slope of the land that will allow smooth movement of the liquid in transit. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Saralana binti Azizia and my matrix number is 01DKE21F1084. And I'm going to talk about 5 main errors in leveling. The first one is instrumental errors. One of the errors is shaky tripod. A shaky tripod makes the device unstable, resulting in incorrect results. The next main error is errors of manipulation, like careless leveling up of instrument. While obtaining readings, the device should be accurately leveled and the hand should not rest on the tripod. The third main error is error due to settlement of level and stuff. For settlement of level, if the level is set up on soft ground, it may gradually settle down in the interval between taking a backside and the foresight reading. It will make the foresight reading smaller than it should be. The level should be set up as far as possible on solid ground and the legs of tripod firmly pressed into the ground. Also, the foresight reading should be taken as soon after taking the backside reading. In soft ground, the legs of the tripod may be set over long wooden stakes driven firmly into the ground. For settlement of stuff at change point, if the stuff is held on soft ground, the ground may settle during the time the instrument is shifted and be set up on the point. The backside will become greater than it should be. This is a serious source of error that can be eliminated by avoiding soft ground as change point. In case the soft ground being unavoidable, a long pad driven into ground or a steel forklift should serve as change point. Next is common mistakes in leveling. I have listed 5. The first one is leveling stuff not being fully extended. The second one is the stuff held upside down. The third is reading the stuff upwards instead of downwards. Fourth one is entering the reading in a wrong column. And the last one is reading the wrong number of meters. And the last main error is error due to natural causes. Error in surveying may also be due to variations in natural phenomena such as temperature, humidity, gravity, wind, refraction, and magnetic declination. If they are not properly observed while taking measurements, the results will be incorrect. We all contribute ideas to the team on how effective the discussion was. We achieved good job outcomes after working together to complete this task. We assign work to each member in an appropriate way. My teammates are quite helpful because we discussed together if we didn't understand something, especially the calculation, and we solved it well. And finally, our task has been complete.